Okay, we're going to start looking at annuities. Now, a lot of the harder HSC questions in the past have always been about annuities. It's always been towards the end of the exam paper, and I don't think that will be any different with this new course. So basically, instead of depositing a one-off amount like we did with compound interest, we just put in one lump sum at the start and it earned interest. We're now putting in regular installments. So we might be putting in, say, for example, $100 a month, every month, and it's earning interest. So let's have a look at this example. Each year I deposit $1,000 into an account for my son. The first payment was made on his first birthday, and each subsequent payment is made on his future birthdays. So the first payment is made at the end of the first year of his life. Now, questions can have payments being at the start or the end of a period, but mostly in our textbook here we have payments being made at the end. So I'm going to mainly focus on that, but I will mention what happens if it's made in the start. If you really develop these skills well and follow the tips you're given, you'll be able to deal with either situation. So each year, interest is paid into the account at a rate of 5% per annum. How much will he have after his 4th birthday? So the important thing is here, one of the important things is the rate. So it's 5% per annum, but remember we write that as a decimal, so it's 0.05. This is all annually, there's no mention here of anything being monthly. Generally, your interest is going to compound at the same time that the payments are made. It doesn't have to be the case. If they wanted to make it really difficult, they could make that change, but it's actually not that much more difficult if you think it out very carefully. So let's have a look. So at his first birthday, he's got that $1,000. We can call that A1. Okay, that doesn't get any interest because it's only just gone in. It hasn't been there long enough to get interest yet. If I'd made that deposit at the start when he was born, after a year it would get that interest, but in this case, no interest yet. So his second birthday, that's our A2, it's equal to that amount at the start plus some interest on it, so 5%, so just like compound interest, 1 plus R, and that's just once because it's 1 year, plus he gets another $1,000, and we're going to start seeing here a recurrence relationship. Our recurrence relationship is that AN is the previous one, AN minus 1, times the 1.05 plus the 1,000. That's our recurrence relationship that we can see right here. It's really important to write that line with the A2 and the A1 in it to see that recurrence relationship. So that works out being our A1 is that $1,000 times the 1.05 plus another $1,000. Okay, let's look at what happens next. Oh, that incidentally equals $2,050. So at his third birthday, his A3, he's got that A2 amount with interest on it plus another $1,000. Okay, so that A2 amount was that 2050 with interest, just like compound interest, 1 plus R, plus the $1,000, and that ends up being $3,152.50. And then on his 4th birthday, so A4, it's the A3, the previous amount, with interest like compound interest, plus another $1,000. Okay, so that's that 3,152 times the 1.05 plus 1,000, and that equals the grand total of 4,310.13. Now these problems can also be done using tables. So there is a table in your textbook. This is what it looks like. It's pretty huge. If you look at the title on that table, it's the future value of an annuity with a contribution of $1. So if you're doing $1,000, you just times it by 1,000. And that's done at the end of each period. So you're basically going to get an extra period when it's done at the start of a period. So if we look at that particular question with the table, remember our R was 0.05, and we wanted to know till his 4th birthday, so that's n equals 4. So 0.05 for our R, n equals 4. So let's come up to our table. You can see I've put a dot next to it. So it is our 5%, our n equals 4, 4.3101. So 4.3101 is our number. Now have a look already, looks pretty familiar. That's on $1, so we have to times that by 1,000. And in this case we're going to get $4,310.10. Not exactly the same as what we had, but that's because of rounding. This number here is rounded to 4 decimal places. Now you can also use that table for the reverse process. So if we want to work out the amount needed to invest at 7% per month for 2 years, so that we'll end up with $10,000, then it's some number times our number from the table to end up with $10,000. Okay, so if we look at our table, 7% per month for 2 years. So 2 years, so it's 7% per month is our percent rate. 2 years, there are 12 months in a year. That's 24 months. So we look in our table under 7% and 24 months. So if we look up here, 7% is down this column. Okay, I've put the little dot there, 24 months. Our number is 58.1767. So that goes in this box here. So 58.1767. So now, of course, all we have to do is divide. So our x equals our 10,000 divided by that 58.1767. So 10,000 divided by 58.1767 gives us $171.89 per month. Okay, that's a monthly amount that we have to pay. Now, interestingly, I did round down there because I rounded down. If we put in $171.99 for 24 months, we're actually going to be slightly under the 10,000, but not by very much. So it's not that big a deal at this point, but it is just something to be aware of.